Let's look at another example of building a function from a word problem. So here I have a rectangle that's inscribed in a semicircle of radius 2. So semicircle is just half a circle, and the radius here, so the distance from the center to the circle is 2, and we're going to let P be the point XY in quadrant 1. That's a vertex of the rectangle, and it's on the circle. As you can see here, P is right here, and it's a vertex of the rectangle, and it's also on this circle. I want to do the following. I want to express the area, A, of the rectangle, so the area here, as a function of x. So I want a function that is only in terms of the variable x. So no y's in that function. And I also want to express the perimeter. So the perimeter is the sum of the sides as a function of x as well. Then I want to graph these two functions, the area function and the perimeter function. So let's start with part A. So express the area of the rectangle as a function of x. So how do we find the area of a rectangle? So what's the basic formula? Area is equal to, well, we have a base, which we usually call B, and a height, which we can call h, or you can say length and width, it doesn't matter. And area is just base times height. So whatever you name these two sides, you multiply them together, and that's the area. And for part B, now we're not done with this, but we're just at least starting it. And for part B, we know that the perimeter is the sum of the sides. So if this is B and this is H, well, we know this side is also H and this side is B. So the perimeter is the base plus height plus base plus height, so 2 bases and 2 heights. Okay, so at least we know what the area and the perimeter of a rectangle are. Now I want to rewrite these formulas in terms of just x. Is that possible? Well, let's see. We know at least that this point here, P, is x comma y. And to figure out y, we plug the x value into this equation. In fact, let me scratch this and say that this is x comma square root 4 minus x squared. Because that is a point, this point, although it's a vertex of the rectangle, it lives on this semicircle, which tells me that the y values will always be given by this equation. So we can just replace this y with this piece here. Now, the point P is how far you go to the right and up, right? This x value tells you how far you go this direction to get to this point, and the y value tells you this direction, that length of this side. So this length right here is x, and this length is y, or in other words, square root 4 minus x squared. And look, I've already got the length of one side of the rectangle. Let's erase this height and put that length here. This is the square root of 4 minus x squared. And then we could also put that here. Square root 4 minus x squared, here and here. Now what about the base? Well, this is a rectangle, right? And half of it is centered here. So this part, this is the same square. For this piece here, we have the same square here, or rectangle. Square is a type of rectangle, right? So this length right here is also x. So that tells me that the base is 2x, x plus x, which is 2x. And that tells me that this is 2x and this is 2x. So now we can fix these formulas. Base times height, well, that's 2x times the square root of 4 minus x squared. And then the perimeter, I've got to be very careful with this. So 2 times the base, so that's 4x, because we have two of them. 2x plus 2x is 4x. And then plus 2 times the height, square root 4 minus x squared. So now we came up with an area formula, which we can say a of x, a for area. So the area is in terms of x. You see that's the only variable. So let me scratch this. And this perimeter we can say is p of x, p for perimeter. Just renaming this formula. And we came up with two equations that are in terms of just x, exactly what we wanted for part A and B. Now let's graph these two functions and find the value of x. So x that we're plugging in to this equation that gives us the largest area and the largest perimeter. So let's start with this one, 2x square root 4 minus x squared. So let me pull up, I like to go to desmos.com, so desmos.com like that, and then just hit graphing calculator, and I'm going to put in my formula. So you can call it A or Y, whatever letter. So let's say A for area. You call it capital A if you want. Capital A is equal to, let me look at this, it's 2x, then just put SQRT, you get square root, and then 4 minus x up 2. Okay. And we want to know when it is the largest, right? For what value of x is A the largest? That means largest means the maximum, right? So we need to find the maximum value. A is the y values. So where is the y the biggest? What's the biggest y value you can have, or the biggest number in the range? So looking at the y values, the biggest y value is right here. And that is when x is 1.414. We take on the biggest y value. So the area when x is 1.414 is 4. So let's write this down. So for part C, when x is 1.414, the area takes on the maximum value, is a maximum, and that area is equal to 4. So if you choose anything bigger than 1.414, and the biggest you can get is 2. Well, first I want to mention that, by the way. Look at the domain of this function. It's from -2 to 2. Why is that? Well, it's actually from 0 to 2, but it's because we can go out all the way here to -2, that radius. That's the furthest that this point can go out. That's why we're going from -2 to 2. Notice that we wanted this point to be in the first quadrant. So this point x, the x values that we were really looking at, is from 0 to 2. And if we look back at this, anything from 0, the area up until 1.414 will be less than 4. And anything past 1.414, the area will be smaller than 4. Notice that if x is 0, or if x is 2, then the area is going to be 0. Why would that be? If x is 0, then our rectangle would look like this, a straight line. And there's no area for that, right? Because there's no, there's not a base here. The base is 0. We just have an up. And if if x was equal to 2, then we would have a straight line here. But by having anything in between 0 and 2, let's say the point P was 1, let's say it was a half. If it was a half, then you would have a rectangle like this. So this point, by moving it up and down, will change the size of this rectangle, right? If I move it here, this point's going to be here, and we'd have this rectangle. And if I moved it instead, let's say I put it this point here, and then I'd move this one here, and I'd have a rectangle like this. What I'm saying is the area here is going to be smaller than the area when x is at 1.414. So right between 1 and 2. And that kind of makes sense. Like this rectangle you see here, you would think the area is bigger than what you see here. Okay. Now let's graph the perimeter function. So I'm going to erase this graph that I have, and we're going to put in 4x. So let's erase this. Say p is equal to 4x times the square root. It was plus 2 square root plus 2 square root 4 minus x squared. So make sure that square root goes over this whole piece. So square root 4 minus x squared, and just double check. It's really important that you put the right equation in. And we want to find the value of x when p is the largest. And that's finding the maximum. And notice that we have a maximum right here. I'm going to move this graph over so I can see it a little bit better. Zoom in some. You can see that the maximum is right here, and if I click on the graph, it'll show me where the maximum is. So when x is 1.789, let's write that down. So D, x is 1.789, the perimeter is at a maximum. And let's figure out what that maximum perimeter is. So the maximum perimeter is 8.944. So 8.944. Okay, we've completed this problem.